Okay, so let's get started. We're going to be taking a look at how to build out our main spark timing table for programming in our Link G5 and G4X systems. Now, our main spark timing table is going to be super important that we have calibrated correctly. It's going to allow the engine to make the maximum horsepower and torque and avoid knock and pre-ignition. What we're going to find in this tutorial is as we start calibrating and tuning our engine, we have to have a safe starting point for that spark timing table. So we want to have something that's going to be a reasonable starting point that we're going to have, let's say 80% of the torque output out of the engine. We may not reach maximum brake torque, but it's going to avoid putting the engine into potential knock and pre-ignition conditions so that we damage it. We need to actually calibrate our air and fuel model first. So whether in volumetric efficiency mode, the model mode, or you're tuning in traditional mode, we need to work out our fueling first, then come back and turn our attention into spark timing. We can actually tune the fuel and the spark timing separately, and that's how I always do this. So the order of operations is always tune the fuel first, then deal with the spark timing. But we have to have a spark timing table built out that gives us a reasonable starting point. Again, we're not trying to find maximum brake torque right away. What we're trying to do is get the engine up and running so that it drives pretty reasonably. We can calibrate our fuel and airflow model. We get that worked out. Then we can turn our attention back into tuning the spark timing. Very, very important that you follow that order of operations. We need to learn how to build a base spark timing table that's going to be suitable and safe for the engine that we're running and tuning. So if we're tuning a naturally aspirated engine versus a forced induction engine, the spark timing that we're going to call out and how the table is shaped is going to be different. It's also going to be different depending on what the compression ratio of the engine is going to be, and as well as the fuel that you're running. So whether you're going to be running, let's say, ethanol, or going to be running petrol fuel, we're going to keep things simple and just assume that we're going to be tuning on petrol fuel with a relatively average compression ratio of something like 9 or 10 to 1. Let's jump in here and take a look at how to set up the spark timing table, just going through the basics and the general configuration and setup. So we're going to move from our basics page here and jump over into our Spark page. Now under Spark, we find we have our main spark timing table. We've discussed this heavily in that last training module. You should understand what the values represent in terms of our compression stroke or the combustion stroke, depending if the values are positive or negative here in the table. What we're trying to do is put safe values in here that make sense, again, for what we're working with. Let's first talk about setting up this table for a naturally aspirated engine. So this is going to be no forced induction, no turbo, no supercharger, naturally aspirated, and we need to have something in here that's going to make sense. So it allows us to run the engine safely, but then dial in our fuel and come back in and touch up the table and try to see how close we can get to maximum brake torque. Now we're going to talk about the actual tuning process with spark timing using a knock sensor. It's actually relatively easy to dial in the values when we look at our knock control. We're going to get into that in upcoming training modules. All we're caring about right now is building out the table so there's safe starting values. So first thing I want to evaluate here is where my engine is going to go and operate at. So naturally aspirated. I know I'm not going to be going above 100 kPa or even 110 kPa. 100 kPa is approximately sea level map pressure reading. So that would be the highest technically the engine can go ahead and bring in terms of the map pressure reading. We may get a ram air effect depending on the intake, so you may go a little bit higher than atmospheric pressure, so there's a possibility of that happening. We want to scale out the table, so it's going to be allowing us to have a little bit past the maximum that we expect the map pressure to read, as well as scaling the table past the maximum we anticipate revving the engine to. So if I anticipate bringing my engine up to 8,000 RPM, my breakpoints here shouldn't stop at 7,000 RPM. Likewise, when we're taking a look at the table, my breakpoints here in map pressure in the load input go from 0 to approximately 240 kPa. Now between 120 to 240, this is positive manifold pressure. So if we're tuning a naturally aspirated engine, this does not make sense in terms of having the table having these extra values. We can shrink the table down. This gives us no benefit by having all of that extra resolution in the table and the extra cell points. So we want to make sure that the table is scaled based on what we're trying to do. Naturally aspirated here is our first example. Let's talk about this. So the first thing I'm going to do here to simplify the table is to go here and get rid of everything above 120 kPa in the map pressure reading. I'm going to click X here and I'm going to jump into the table and we're going to go ahead and just start to delete the values. So we have one here at 140 and above. I'll click on 140 and use my X, and then I'm going to go here and just keep clicking X and delete the rest of the values and click OK. Now when we do this, we can see the table's going from 0 to 120 kPa. Now, technically speaking, the engine's only going to be able to go up to atmospheric pressure, which is approximately 100 kPa. But again, if we get a ram air effect from the intake we're running on our naturally aspirated engine, it is possible to build a small amount of positive manifold pressure, and we want the map pressure to be able to see that positive manifold pressure. So we're going to scale slightly past the highest load we anticipate the engine seeing. So in this case, 120 kPa in my map pressure input or load axis to the table. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.